Hey, I'm Liz, and I'm a developer advocate at Evervault. And today we're going to look at a demo of how you can run a sensitive model inside of a cage. So, why would you want to do this? There's a couple of reasons. The main one is if you have a model that is proprietary and you don't want anyone to get a hold of it, but you still want to be able to run it in the cloud, then you could run it inside of a cage and it couldn't be accessed or tampered with by anyone else. The other is if you're running sensitive data through that model. So in this example, what we're doing is we are using a brain segmentation model, and we're going to feed it a sample image and use it to detect if there might be tumors within that sample image. So we have kind of an example here of what the sample image looks like, and then the output simply puts a little masked overlay over where a tumor might be in that image based on the inference from the model. There's a couple of setup steps that are required. So we've already gone through that. If you want to pause the video now and set that up, you're going to need an AWS S3 account, a Docker application install, and you also want to have Docker running because we'll use Docker to deploy the container inside of the secure enclave. And in order to do that, you need an Evervault account as well. So you can set that up for free. So go ahead and do that. And you also are going to need the code that we'll use for this, which is all available on GitHub. You can find it at Evervault examples or down in the description below. We are providing a pre-trained model with weights if you want to use that. Of course, it is going to be based on how we trained it. But if you wanted to do it yourself, the model that we used is here on Google Colab, and it is free to the public. So feel free to have a play around with that if you'd like. So once you have everything set up, you can head over to your code editor and we'll take a quick look at the app that we're actually going to be deploying inside of the cage within the Docker container. So if we take a look here, what we're doing first is we're just going to get the model from our S3 bucket and download it. Then we're going to start running inference on it, and we're going to apply that mask over the image and then simply just output it back and send it to our client. We'll make a call where we pass the sample image in, which will then hit the cage and kick off this whole process. But again, it will be secure. No one will be able to see the model. And you could even encrypt the image so that the image file itself would stay protected until it hit the cage and would only be decrypted once it was in the cage. So let's go ahead and start the build and deployment process for sending this application into the secure enclave. We need to start out with initializing the cage. So we'll do that with the evcage init command. We need to pass in the Docker file. And actually, let's take a look at the Docker file really quick too, just so you can see what that looks like. This is our Docker file. One sort of best practice for working with Docker files when you're using Python with secure enclaves is we recommend creating a virtual environment and using all of the packages that you need to install within there. You also want to try to use a slim version of Python to keep the image as small as possible. And then you just need to expose the server on wherever it might be running. We're using Flask for this. So wherever your Flask server is running, you want to expose that endpoint as well. So we'll pass in our Docker file, and then we just need to give the cage a name. And we also need to disable the API key authorization. This step isn't required. The reason why we used it for the sake of this demo is if you did want to run the cage without requiring API key authorization, maybe you want to set up a CI/CD pipeline or something like that, then that is possible to do. So now that we've run that, we'll see that we have a few things that were just generated for us. The first is the cage toml, which has a bunch of information that's helpful to know about your cage. You'll see that we have left logging true by default. So if you want to check the logs in your Evervault dashboard, that will give you some information about what's happening in your cage. And also everything that you need for the signing process. which are these two files here. Okay, so the next thing that we need to do is actually build the cage. So we'll do that with the evcage build command. And we'll get this started. This process may take a little bit of time. So check your email, grab a coffee. I'm going to fast forward through this and I'll meet you at the end of when the build runs. Okay, so after a couple of minutes, your cage should have built. You'll see the success message here, and it will let you know that your EIF file has been built. It'll also spit out this list of PCRs, and these values are what you need to use to attest that everything that's running in the cage is what you intended to run. And the way that you'll do that is in the next step when we make a call from our client to the cage and pass in the sample image. So the very last step that we need to do before we get there is just to deploy the cage. So we'll do that using the evcage deploy command. And we just need to pass in the path to that EIF file. It should be something like enclave.eif. Once your cage is deployed, it will verify that you've deployed it with the correct attestation measures. Then the last step is just making a call to the cage and seeing if we get our response image. You could do this using a curl request, or you could do it using a script. We set it up in this example as with a script, just to simplify the process a little bit with uploading the sample image. So this is what that script looks like. We do need to pass in the PCRs, so make sure that you copy those over. You could also put them in a config file and use them there if you'd rather do that. And then the format of the request is just the cage name, the app ID, and then whatever endpoint you defined in app.py, which we used upload here. So let's go ahead and run this and see if we get our image. And you'll see here that we did, in fact, get that response image with everything overlaid. Thanks so much for watching this video. Now you've been able to run a model inside of a cage. There's only CPU support, which does limit some of the machine learning tasks that you'd be able to do, but there is still a lot that can be done. And we'd love to hear about whatever it is that you're running inside of a cage. So let us know in the comments. You can also join us on our Discord. There's some conversations going on over there about cages. So join in on those. Let us know how things are going for you. And we can't wait to see what you do with cages. You can also find the links to the guide and the code repo in the description here. And if you want to learn more about cages generally, be sure to check out this video here and subscribe to our channel for more updates on cages. See you next time.